Okay, in this lesson we'll begin discussing the dot product. So 11.3, the dot product. So let vector A be the vector with components A1, A2, and A3, and the vector B be the vector with components B1, B2, and B3. The dot product of the vector A and the vector B is the scalar. We're going to put scalar in all caps so that we remember when we take the dot product, we no longer have a vector, we just have a number. Is the scalar A dot B, and that's red just as that is red. A dot B. Now, why is that important? Because we have two types of multiplication for vectors. This is the dot product. We'll talk about later what's called the cross product. But you don't want to say A times B, because then nobody knows which one of the products you're talking about. Are you talking about a dot product or a cross product? So we avoid times or multiplication. And when we're talking about two vectors, we say either dot product or later on we'll say cross product. But you're going to say some kind of product and specify which type of product that is. So that's why I just read A dot B, not A times B or anything else. And it's given by A dot B equals, now how do we compute the dot product? What you do is you're going to take the corresponding components of the vectors, which these are numbers, so we're just going to multiply those. So we're going to do A1 times B1. So A1, B1, and then plus A2 times B2. So A2 times B2, and then plus A3 times B3. And notice this will just be some number. So that's why our dot product is a scalar. All right. Now, if A is not equal to what's called the zero vector, it's just a vector where all the components are zero. And we also denote that by that a zero with the vector hat on top. And B is not the zero vector. And theta between 0 and pi is the angle between A and B. And I'll talk about in more detail what I mean by the angle between A and B. Then A dot B is equal to the magnitude of A times the magnitude of B times cosine of theta. And cosine of theta, so I'm just going to solve this equation right here for cosine of theta. So cosine of theta is equal to A dot B divided by the magnitude of A times the magnitude of B. And notice here, we don't have to be concerned about dividing by 0 because we know that A is not the 0 vector, nor is B the 0 vector. So the magnitude of the 0 vector is the only vector that has magnitude of 0. So we know that this number is not 0 and that number is not 0. So we're not concerned about dividing by 0, given we specified neither A nor B with a 0 vector. Now, so this is a different way that we can compute the dot product. So if we know the angle between the two vectors, but let me talk about more about what the angle is between two vectors, because we're pretty clear on an angle between something in the x-axis, but we don't regularly talk about an angle between two vectors. Even if you were introduced to vectors necessarily in 2 dimensions, you may not have discussed an angle between two vectors. So we normally discuss angles in a plane, and we're not necessarily in a plane when we talk about vectors. So say I have, we'll make this one vector. This is one vector, and then I'd have down here some other vector. All right, so these are my 2 vectors, and I want to talk about the angle between them, but they're not even remotely close to one another. But somehow I have to discuss an angle between those 2 vectors. Now remember, vectors in space, as long as we don't change their length or their direction, they can move wherever we want to move them. So what you would do is you would take those 2 vectors and you would put their initial points to where they meet one another. And you have to put their initial points. So we're assuming that the tips of these pen caps are the tips of the vectors. So now I move those vectors. I didn't change I might have changed their direction. I was trying not to. I certainly didn't change their magnitude. So I can move this wherever I want to as long as I don't change its direction. I can move this wherever I want to as long as I don't change its direction. What I'm going to do is I'm going to move them so that their initial points or their tails are right next to one another. Now that I have their tails next to one another, those 2 vectors, now that I have their tails right next to one another, it still may not be apparent what the angle is between them, but any 2 vectors form a plane. So now I can take this plane and notice those 2 vectors will hold that plane up. So, but I of course want to see the vectors. So now I can trace in that plane what the angle is between those 2 vectors. And that's how we would determine what is the angle between 2 vectors. So although these vectors began here and here, we take them and we put their 2 initial points together, and then they form a plane. And in that plane, we take the angle between those 2 vectors. And that's what this theta is that we're talking about here. So now with that, we have a new formulation or a different formulation of the dot product based upon the lengths of the vectors and the angle between those 2 vectors. All right, so let's look at an example. We'll do an exercise from your all's textbook. We'll look at page 728, number 2. So in exercises 1 through 4, find A dot B and the cosine of the angle theta between A and B. So they give us 2 vectors. And what I'll do is I will try to remember to write the vectors in a different way in the notes than they're written in the textbook, just so that you can see both of the ways to write them. So they use the IJK notation in the textbook. I'll use the pointed brackets here. So the vector A is 1/2 and 1/3 and -2. And the vector B has components 2, -2, and 1. 2, -2, and 1. So they want us to find the dot product. So we can use So we have two options. We have this initial definition that was given, and then this reformulation of the dot product that was given here. So because they want us to find the dot product as well as find the cosine of the angle between them, we're going to have to use, we know for sure for the second part of the problem, we're going to have to use this. But even in using this, we still need the initial dot product. So we're going to start with this, and then we're going to use this after that. So starting with this formulation, A dot B is equal to 1/2 times 2 plus 1/3 times -2 plus -2 times 1. So now we'll simplify this. And what does that give us? We have 1 minus 2 gives us -1 minus 2/3. We get -1 minus 2/3, which gives us -5/3. All right, so that's the dot product. So then they also want the cosine of the angle between the two vectors A and B. So we're going to use this now. So in order to use this, notice we need the magnitude of A and we need the magnitude of B. So let's go ahead and find those. Let's go ahead and find those two values. So the magnitude of A is equal to, so remember we discussed the formula for magnitude or length of a vector. So it's going to be 1/2 squared plus 1/3 squared plus -2 squared. So we end up with a square root of 1/4 plus 1/9 plus 4. And we'll go ahead and simplify this. Actually, we'll simplify after I see what the magnitude of B is to see how much we need to simplify. The magnitude of B, using that same formula, is the square root of 2 squared, which gives us 4, plus -2 squared, which gives us 4, plus 1 squared, which gives us 1. So this one just gives us 3. So now what we have to do is put this, and this into that formula for cosine of theta. So cosine of theta equals, so cosine of theta equals our -5/3, which is our dot product, divided by our magnitude of A, which, let's put our magnitude of B in the front. So first our magnitude of B, I put that in the front because it's easier. 3, and our magnitude of A is the square root of, let's see what we have. We have 9/36 plus 4/36, 13/36 plus 72, 144/36. So 157/36. So we've got some messy numbers here. So that's -5/3 over 3 times the square root of 157/36. So we can simplify this somewhat. So this is -5/3 divided by 3/6, or 1/2, because I'm bringing out the square root of 36, and then times the square root of 157, which gives us -10/3 times the square root of 157. All right, so the cosine of the angle between our two given vectors would be this value right here. All right, so what we'll do is we'll stop there for this video of 11.3, and then I'll continue 11.3 in the next video.